Hello friends, how are you? Omar Sharif is here. Today we will see Unit 1 Sequence and Series. In this chapter, we will see what sequences are, what series are, and how to solve, how to organize, how to manage sequences and series. We will show this. Now we are going to see what sequences are. Sequences. The word sequence used in every conversation, usually referring to a list of things occurring in a specific order. In mathematics, a sequence is viewed as a set of numbers, one comes after another in a given rule. That given rules may be a gap and another. Recognizing and identifying patterns is a fundamental idea that appears in science and mathematics. It serves as a fruitful starting point for analyzing a wide variety of problems. Now we will see that what sequences are. What is sequence? Sequence is a function whose domain is the set of positive integers or a subset of consecutive positive integers starting with 1. The functional values a1, a2, a3 up to an up to infinite are called the term of sequence. Those are the term. And an is called the general term. That means, or we can say that the nth terms of the sequence. Now we must know some terms. The sequence a1, a2, a3 up to an and up to infinite is also denoted by this one, and the sequence can be described as listing the term in formatted. One, by listing the term, sequence can be described by 4 terms: listing the term, drawing graphs. The third one is writing the general term. The fourth one is using recurrence relation. Now we will see one example for this. By associating each positive integer n with its reciprocal, considering 1 over n, we obtain a sequence denoted by this one, 1 over n, which represents the sequence of a number starting with the term 1, 1, 1 over 2, 1 over 3, 1 over 4, up to 1 over n, up to infinite. The general term is an, which is equals to 1 over n. Another example, consider the sequence n is equals to 1 over to the power of n minus 1. We obtain a1 equals 1, a2 equals 1 over 2, a3 equals 1 over 4, and so on. List up to 10 group we can list. Let me see another example. Given a certain terms of a sequence, say 2, 4, 6, 8, which one of the following can be its general term? 1, n is equals to 2n, or n is equals to n minus 1 into n minus 2, n minus 3 up to n minus 4 plus 2n, for n is a positive integer. And a sequence that has the last term is called a finite sequence. If the sequence has a last term, simply we call that a finite sequence. And a sequence that does not have the last term is called infinite sequence. If the sequence start and if there is a last, it goes to the infinite. Therefore, this sequence is said to be infinite sequence, and the domain of the finite sequence is 1 up to n, and the domain of infinite sequence is natural number. Start from 1 up to infinite. There is no limit. For instance, 1, 2, 3 up to 10 is a finite sequence, and 1, 2, 3 up to infinite, this is an infinite sequence. By the way, some sequences do not have a sequence defining formula. For instance, the sequence within branch of Pn, where Pn is the population of one country in 1 year, in n year. Therefore, this does not have a simple defined formula. And another example, if we let an to be the digit in the nth decimal place of a number root 2, then the sequence an is well-defined sequence whose first few terms are 4, maybe 4, 1, 2, 4, 2, 1, 3, 5. You can say that. The formula that relates the general term of an of a sequence to one or more of the terms that come before it is called a recursion formula. A sequence that is specified by a given few terms. First few terms together with the recursion formula is said to be defined recursively. For instance, the question finds the first 6 terms of the sequence an defined recursively by a1 is equals to 2 and an is equals to an minus 1 over n for n greater than or equal to. Given a1 is equals to 2, a2 is equals to a2 minus 1 over 2. This means a1 over 2 is equals to 2 over 2 is equals to 1. a3 is equals to a2 over 3, a4 is equals to a3 over 4, and so on. Therefore, we get finally the first 6 terms of the sequence for the sequence of an are 2, 1, 1 over 3, 1 over 2, and so on. Sequences for this sense, there are you can divide the sequence in two ways: arithmetic sequence and geometric sequence. What arithmetic sequences are? Arithmetic sequence or arithmetic progression is one in which the difference between consecutive terms is a constant. This constant is called common difference. And the sequence an is an arithmetic sequence with a common difference d if and only if a n plus 1 minus an is equals to d for all n. If the sequence a1, a2, a3, and an is an arithmetic progression or arithmetic sequence, therefore a2 minus a1 is equals to a3 minus a2 is equals to a4 minus a3 up to an plus 1 minus an is equals to d. Equivalently, a2 is equals to a1 plus d, a2 is equals to a3 minus d, or a4 is equals to a3 plus d, or is equals to a5 minus d. We call this sequence arithmetic sequence or arithmetic progression. Now, if the sequence an is an arithmetic progression with the first term a1 and a common difference d, then the nth term is given by an is equals to a1 plus n minus 1 d. Therefore, we can solve any terms by using this formula. Given an arithmetic sequence with the first 5 and common difference 4, find the 5 terms and the 20th term. It is simple. Firstly, we take the given and a1 is equals to a5, a2, and the common difference is 5. The common difference is 4. Excuse. Therefore, a2 is equals to a1 plus d, 5 plus 4 is equals to 9, a3 is equals to a2 plus d, 9 plus 4 is equals to 1, 3, and so on. The 20th term is, we can see that a20 is equals to a1 plus 20 minus 1 times 4. That means 20 minus 1 is 19, therefore a20 is equals to a1 plus 90d. That means 5 plus 90 times 4 is equals to 81. We can see another example given an arithmetic sequence whose first term are minus 3 and 7. Find the next 3 terms and the 14th term. Given the first term, that means a1 is equals to minus 3 and a2 is equals to 7. We know that a2 is equals to a1 plus d. Therefore, d is the difference of the first two consecutive terms. That means 7 minus minus 3 is equals to 10. For d is equals to 10. Therefore, an is equals to a1 plus n minus 1 d, where d is 10, and at this time, the next three terms, that means a3 is equals to a2 plus d, a4 is equals to a2, a3 plus d, and so on. Therefore, the three consecutive terms 17, 27, and 37. Another example shows that the sequence to n minus 1 is an arithmetic sequence describing sequence graphically. By the way, the graphical representation is not necessary. Therefore, we can show that in simple term, an is equals to n minus 1. That means d is equals to a n plus 1 minus an is equals to d. Therefore, n plus 1 is equals to 2 into n plus 1. Instead of n, we substitute n plus 1. Therefore, n plus 1 is equals to 2n minus 1. D, the common first d, is an plus 1 minus an minus an minus 1. We can see that. Therefore, when you subtract those two terms, we get a constant number. If you get a constant number, therefore, that sequence is an arithmetic sequence or arithmetic progression. Let me see one problem to clear our lesson. Therefore, let's do.